Okay, so for this lesson here, what I would like you to do is to have your notes out. You're also going to start by working on a simulation. You're not really going to need a periodic table for this and no calculator. So our point today is to be able to solve and balance equations in order to satisfy the law of conservation of mass. And we touched on law of conservation of mass at the start of the school year, and so we'll revisit it again here. Now, the first thing I'm going to have you do is this introductory activity, and I'm going to have you go to the PhET website to use their balancing equation simulator. And I want you to play with that for a few minutes. So there's the link. I'm also going to put it here on the side for you to click on. And then I want you to select Introduction, and then under Tools, change it to None. Okay, and use the simulator to help you determine what a balanced equation is. And I want you on your paper to write what you think a balanced equation is, because then you're going to submit it to me, so I have an idea of your understanding. So pretty much the idea of a balanced equation is that each side of the equation has the same number of atoms of each element. When we were predicting products, I know some of you were bothered by it wasn't even on both sides, and I said, oh wait, later on we're going to take care of that. Well, this is the point where we are going to take care of that. And the whole reason we do that is to satisfy the law of conservation of mass, which says the mass cannot be created nor destroyed, it's always conserved. So what it's saying is the mass you start with has to be the mass you end with. It can't come out of nowhere, okay? Those atoms have to come from somewhere. So here's your basic rules. If you're given an incomplete equation, like you were with the last section, where you have no products, you want to complete the reaction by predicting products with the correct formulas and physical states if necessary. It looks like I missed a parentheses right there. At this point, you can modify subscripts if needed, because you do that in order to make the charges cancel out. So like if I have Na plus Cl2, okay, what I was having you guys figure out is +1, -1, and then you get NaCl. So that's what we were working on last week. But what you had here is you had this uneven amount. You had a 2 there and then nothing there. So that's what we're going to fix today. So really what you're going to do next is count and compare the number of atoms of each element in the reactants and products. So just like the example I drew, I had 2 chlorines on one side and only 1 on the other side. Now, at this point, I want to balance the equation by adding coefficients. I can't change subscripts at this point anymore, okay? It's only in that first step can I do subscripts. And then I want to check each atom and polyatomic ion to make sure the equation's balanced, and reduce it to the lowest whole number ratio if that's possible. So really the steps you're just going to end up doing automatically because you just get used to it. But if you need a process to follow, that's what you're going to go through. Okay, so let's take a look at the second one. It dropped down there first for a reason. So if I look at the reactant side, I have 2 hydrogens and 2 oxygens on the left-hand side, on the reactant side. But then on the other side of the equation, I have 2 hydrogens, but only 1 oxygen. So this is an unbalanced equation. Now, as I was saying, you can't change the little numbers underneath. I can't just put a 2 there to fix it. That would be H2O2, which is hydrogen peroxide. That's not water, okay? If I were to change that to hydrogen peroxide and then you were to drink it, you would die. Okay, so the only thing I can do is to add coefficients, big numbers in front. So I can put a 2 there. That now changes my oxygens to 2, but it also changes my hydrogens to 4. And so I need to fix it on this side. And again, the only thing I can do is add coefficients. 2 times 2 gives me 4. Now I have 4 hydrogens on the left, 4 hydrogens on the right, 2 oxygens on the left, 2 oxygens on the right, and we say that is balanced at that point. I don't know why I tried to dot that. So that's balanced. Okay. If we look back at the first one, I've got 1 carbon, 2 oxygens, and 2 oxygens. And so these are equal on both sides. So this equation is already balanced without me having to do anything to it. And occasionally you run into those. Okay, so a couple more examples. Okay, I've got 1 magnesium on the left and 3 magnesiums on the right. So I usually just pick the first element or pick whatever looks easiest. It doesn't matter where you start. And so I fix that by putting a 3 in front. And then if I look, I've got 2 nitrogens and 2 nitrogens. So that one is all good now. Okay. At this point, I'd like you to try the next one on your own. All right, so to fix this one, I've got 4 phosphorus and 1 phosphorus right here, so I'll fix it by putting a 4 in front. Okay, and then 10 oxygens and 2 oxygens, so 2 goes into 10 5 times. So if I multiply 5 times 2, I get 10 oxygens. Okay, so those numbers in front are going to multiply on everything throughout. All right, now these are a little different. These have polyatomic ions, but with polyatomic ions, those are actually really easy to balance too, because often you see them on the left-hand side of the equation and the right-hand side of the equation. So like here I see NO3, and I have NO3 also on the reactant side. So sometimes it helps students to draw in the parentheses to kind of remind themselves that they have a group. So on this side, I have 1 of the NO3 group, and on this side, I have 2 of the NO3 group. So I fix that by putting a 2 in front of the silver. Well, silver nitrate. So that's going to give me 2 silvers. I look to the other side, and I have 2 silvers. Okay, so I had to put a coefficient of 2 in the front. All right, and don't forget to check your other element. I have 1 copper and 1 copper. So if I just clean this up, erase my extra marks, okay, that is your balanced equation. So again, we're going to pause right here, and you're going to try the next example. Okay. So another polyatomic ion, actually there's 2 polyatomic ions in this one. There's the hydroxide, I can see that with the parentheses, and then there's this sulfate, this SO4 on both sides. If you were trying to count all the oxygens, that would be really annoying, because here I've got 5 oxygens here and 6 oxygens on this side, and it's just too much to keep track of. But if you look at the polyatomic ions, it's very easy. So here's the hydroxide, OH. And then here is 2 of the OHs, so I need to put a 2 in front. Okay, and then that gives me 2 potassiums. Well, over here I already have 2 potassiums. And I've got 1 of the sulfate group, 1 of the sulfate group, 1 magnesium, and 1 magnesium. So this one was actually very simple to balance. Again, I'm going to erase this to clean up my marks so you guys can see it more clearly. Okay. Sometimes you'll have to put a coefficient in front of all of them, sometimes just one of them. Now, I've said often before that chemists don't like to write ones, so these are essentially invisible ones in front of each one of these, but we don't write them. Okay, but that's what they represent. Okay, now the last one is a little bit trickier, and one of the things I warned you guys a few days ago was water can also be written as HOH, like that. Well, really, it gets written like this. But with the parentheses, you can see I have that hydroxide polyatomic ion. So here's that hydroxide, that OH. And if I rewrite this water as HOH, I see that hydroxide. Well, here I've got one hydroxide, one sodium, one sodium. I have one hydrogen right there, but here I have two hydrogens. So I am going to have to do some, if I go ahead and try and fix that, I have to put a 2 in front. That gives me 2 H's, but that also gives me 2 of the OH's. So I need to fix that by putting a 2 in front to give me 2 of these hydroxide groups. That's also going to give me 2 sodiums, so I need to fix that and put 2 sodiums there. So, like I said, you can rewrite water in some cases as HOH, and then this helps you with your balancing. The last type are combustion reactions, and combustion reactions sometimes can be a little tricky, but what I tell students is, everybody loves chocolate. So instead of trying to balance your oxygen first, you would never start there because you've got oxygen and all these different places. Do the carbon first, hydrogen second, and oxygen third. And if you do that, it becomes a lot easier to balance. So if I look at this first example, do my carbon first. 1 carbon, 1 carbon. Okay, next I do my hydrogens. 4 hydrogens, 2 hydrogens. Well, I can fix that by putting a 2 in front. All right, next I'm going to count up my oxygen. So on this side of the arrow, on the left-hand side, I have 2 oxygens. And on the product side, I have 2 oxygens plus 2 times this invisible 1 right here, 2 more oxygens for a total of 4. So, we do get to add them up because of that plus sign. So I have 4 oxygens on this side, only 2 here. So the way to fix that is to put a 2 in front of that. Okay. So that was pretty easy then, looking at just doing the carbon first, then the hydrogens, then the oxygens. Okay, so we are going to pause again so that you can try the next one out and give me the coefficients. All right, so let's check your answers. Do carbon first. 5 carbon, 5 carbon. Do hydrogen next. 12 hydrogen. So what times 2 will give you 12 hydrogen? That is 6 times 2 will give you 12 hydrogen. Next, I want to add up all my oxygens. So here I've got 10 from 5 times 2. Plus 6 times my invisible 1, that's going to give me 16 oxygen. So a total of 16 oxygen on the product side. Over here I have 2, so I need to figure out what times 2 will make 16, and the answer is 8. So now that equation is balanced. Okay, last example. Again, I'm going to pause and have you guys try it. And we'll see how that one works out. Okay, so we've got 5 carbons, 5 carbons, 10 hydrogens, and here I have 2, so 5 times 2 will make 10 hydrogens. Now I add up my oxygen, 5 times 2, that's 10 oxygens, plus 5 times 1, that's 15. Okay. Well, what times 2 will equal 15? So if I divide 5 into 2, I get 7.5. Well, here's a problem. You can't have half of an oxygen molecule. So the way to fix this is to take this whole equation and multiply all my numbers by 2. Okay? So don't forget here, this is an invisible 1, so even that 1 is going to get multiplied by 2. So now if I do 2 times 1, I have 2 of this pentene molecule. 7.5 times 2 is 15. 5 times 2 is 10. And 5 times 2 is 10 again. Okay. So if we check this, and I'm going to erase, again, a bunch of this stuff to kind of clean this up a little bit. If we check it here real quick, to make sure that we are getting what we need, okay. 2 times 5, 10 carbons. 10 times invisible 1, 10 carbons. Do hydrogen next. 2 times 10, 20 hydrogens. And on this side, 10 times 2, 20 hydrogens. And then lastly here, 15 times 2 is 30 oxygens. And let's draw a little line to keep our products and reactants separate. 10 times 2 for my oxygen, that's 20 oxygens, plus 10 times an invisible 1. That's going to give me a total of 30. I can't write. There we go. Oxygens. Okay? So it does work out. So if you ever get a decimal, like half of a molecule or something like that, multiplying it by 2 will usually take care of the problem that you have. So the remainder of this is you do have a worksheet of problems, and you're also going to go back to 6.2 and those equations that you wrote and balance those equations also.